Hello, welcome to this new video tutorial. This one is for my Year 10 students and we're going to be looking at acceleration. So what we're going to be covering is the basic theory behind acceleration as well as the acceleration formula you'll all need to know how to use. And I'll be going through several worked problems. I'll go through a basic one from our problems worksheet as well as one problem from our 2015 exam and the 2014 unit test. And at the end I'm going to go through one problem that has to do with acceleration due to gravity. Now, acceleration is defined as a change in velocity over time, which I hope that most of you are aware that objects can either speed up or slow down, and that change in velocity is what we mean by acceleration. Now, acceleration isn't a scalar quantity which is only defined with a number, but it is a vector quantity, so that it has both a number and a direction. Now, as opposed to velocity when we talk about direction in terms of north, south, east, and west, acceleration direction depends on the direction that the object is actually moving at. So if something is accelerating, which means it's speeding up, we define that as a positive acceleration. Whereas if it's slowing down or decelerating, we refer to that as a negative acceleration. So instead of giving directions as north, south, east, and west, you'll be defining your acceleration as either positive or negative. So the formula for acceleration, being change in velocity over time, is v minus u divided by t. Now v is the final velocity after acceleration has been completed, with u being the initial velocity. Now acceleration can take place either from a standing point, in which case that initial velocity is 0, or it can be when the object's already in motion, in which case that initial velocity will actually have a value attached to it. And time is of course the time in which this acceleration will take place. Now the units you'll come across for acceleration will typically be meters per second or meters per second squared, which are both different ways of writing the same unit. Depending on the questions, and especially for some on the worksheet we've completed in class, you may get some unusual ones like kilometers per hour, but for the sake of our assessments, our tests and our exams, you're going to be seeing meters per second or meters per second squared. So our first worked problem is directly from our acceleration problems worksheet, and it's a pretty straightforward question which is pretty much a plug and play scenario. So a roller coaster car rapidly speeds up as it rolls down a slope. As it begins down the slope, its speed is 4 meters per second, but 3 seconds later at the bottom of the slope, its speed is 22 meters per second. What is its average acceleration? So if we're looking at our values, we have 4 meters per second, 22 meters per second, and 3 seconds. All of our units match. We have meters and seconds and combinations thereof, so we don't have to do anything with our units, so we can proceed with the question. So if we go back through our worded question, we can figure out what values it's actually given us. Now it tells us that the final velocity is 22 meters per second, so that is going to be our v value. 4 meters per second is the speed that it was at the beginning of its acceleration, so its beginning speed, or u, is going to be 4 meters per second. And the time, of course, it took to undergo this acceleration is 3 seconds. So we go back to our acceleration formula, which is v minus u over t, plug in the numbers, which comes to 22 minus 4 meters per second, divided by 3 seconds. Now, I strongly recommend writing in the units for all of our workings, but especially for acceleration, because then it helps you to determine what the unit's going to be. Now, in this case, if we just work with the numbers, we'll find that 18 divided by 3, which is 22 minus 4 divided by 3, will give you an answer of 6 meters per second on the top, and seconds is on the bottom, so our unit is going to be meters per second per second. Now this is a problem that came from last year's exam, so it's particularly relevant, and it's the kind of question you should expect to see. A police car is travelling at a constant speed of 30 meters per second along a freeway. After spotting a speeding motorcyclist, the police car then accelerates at a rate of 3 meters per second squared for 5 seconds. How fast is the police car going at the end of the 5 seconds? So even though this is an acceleration question, it's actually asking you to determine a velocity as part of the answer. Now all the numbers you need are hidden within the worded question. So here it tells us clearly that the police car is accelerating at a rate of 3 meters per second squared, which is one of our ways of writing the units for this acceleration. So I'm going to write my way of 3 meters per second. They know that the police car is traveling at a constant speed of 30 meters per second to start with, and that after 5 seconds the acceleration is complete. So our time is 5 seconds and our u value is 30 meters per second. Now you can do this a couple of different ways depending on how you like to do your maths. I like to rearrange the formula before putting the numbers in. If you want to put the numbers in first, then please be my guest. You'll still get the same answer. But as long as you start with the right formula of acceleration is v minus u over t, I'm going to rearrange that, bring the t up, which makes at equals v minus u, and then rearrange to have v equals at plus u. Now putting in the numbers, we end up with 3 times 5 plus 30, and that gives us a final velocity of 45 meters per second. Now this is a slightly different question. I'm putting it in because it is one where you have to determine an acceleration entirely from the worded question. And it can be tricky, especially if you're one that doesn't like worded questions all that much. So I'm only going to go through part A. Part B of this particular question, if you look back at our records, is actually pretty similar to the last one, so I'm not going to do it twice. Now in this case, a car is stopped at a traffic lights and increases its speed by an average of 4 meters per second every second during the first 5 seconds after the light turns green. So a lot of numbers and a lot of words, but the question is asking, what is the average acceleration for this car? Now this one you'll have to know our definition of acceleration, which is a change in velocity over time. The question clearly states that the car increases its speed, which is acceleration, by an average of 4 meters per second every second. So if we interpret that to an acceleration, that becomes that 4 meters per second. So it is pretty simple. It is right there in the question. You just have to know what to look for. Now finally, I'm going to talk a little bit about acceleration due to gravity. Usually a lot of our examples for acceleration talks about cars speeding up or slowing down. But acceleration due to gravity is something you're going to come across, especially when we start learning about Newton's laws next week. Now, an acceleration from gravity occurs if an object is dropped and is free falling through space. Given no other factors, any object that is falling will fall at a constant acceleration of 9.8 meters per second. So that means that every second that the object falls, the velocity is increasing by 9.8 meters per second. So after 1 second, if you look at the picture on our right, after 1 second the velocity is 9.8 meters per second, whereas after 2 seconds it is now 19.6, which is 2 times 9.8. At 3 seconds, it is 3 times 9.8, which is 29.4, and you're probably going to start to see a pattern here. So any questions you get that are going to refer to something being dropped off a cliff or dropped from a very high height are going to be these types of questions that refer to acceleration from gravity. So in this question, a rock is dropped from a 150 meter high cliff. What velocity is the rock traveling at after 3 seconds? Now these are very, very simple questions to do, but they can be hard to pick, especially if you fall for the red herring in the question. So you'll know this, but also, even if you don't remember, it is going to be on your formula sheet that the acceleration due to gravity is 9.8 meters per second. Now, the velocity for any of these types of questions is simply that acceleration of 9.8 multiplied by the time that the object is falling, and the time should be in seconds. They're probably going to give this to you, but it's always good to check. Now, in this specific example, the object is falling for 3 seconds, which means that its acceleration after 3 seconds, its velocity after 3 seconds, is 29.4 meters per second. The red herring in this question being the 150 meter height. A lot of people might fall for this being a speed equals distance over time formula question. It is not. The height of the cliff is completely irrelevant to completing this question. The only thing it helps you understand is that the rock doesn't hit the ground. So thanks everyone for watching. Hopefully this helps you to understand acceleration a little bit better. If you need any further help, please let me know. You can put questions and comments in the YouTube links or just email me in class.